So we just looked at a frequency table for a categorical variable. We now move on to looking at a frequency table for a quantitative value. And again, here's some real data from 2020. The 21 states increased their minimum wage in 2020. Here's what they increased them to. And so we want to organize this data so that we can better get a picture of what is occurring with the data. And one way we do that, we end up creating these frequency tables, but we do it first by what we call organizing the data into bins or classes. And you have that description there. And what we do is we count how often a value goes inside of this bin or class, which ends up being called the class width or size or bin width. It's the distance from the start of one bin to the start of the next bin to keep in mind. And so it's not really a bin, right? This idea, it's a figurative idea of looking at bins this way, thinking about, okay, I wanted to create, using this data, I want to create classes or bins, right? Starting at $7 with a width of $1.25. Remember, where the context of this problem, these are the minimum wages for the 21 states who increased their minimum wage in 2020. And so one way to organize it, here are multiple, sorry, not one way, but multiple ways to organize it. And again, it's just symbolic notation. We want to start at 7 and a width of $1.25. You can see I have 7, 825. It's just a way of articulating these bins, how big they are, and then we count how many of these go into it. Now notice the subtle notation here. Sometimes use brackets or parentheses. All of these mean the same thing. They're just 3 different ways, and sometimes you see it 3 different ways. You'll see the representations of class width or bins this way. And so notice from 7 to 825. Now the parentheses do not include, so you're technically only going to $8.24. Here you're going, you would say from lower bound, upper bound, you can say from 7 to 824, but notice we're using a bracket, which means we're going to that value. It's just alternative ways of writing the same thing. You just want to be aware of how we define these class widths, or you can use kind of this range notation here, just with a dash, 7-824. But all of these technically mean the same thing. They're just different notations for the same thing. So if you were going to do, but if you want to try it before I do it here, but you can see it here, pause, but create some new bins from $7 but $1.50 with using the double brackets notation, which is the middle one here. This is what you would end up. Again, what you're doing is you're kind of making a number line, and then you're creating these classes or bins, right? So just make sure, and then so it look like this. But again, it's the representation that's important. You have this number line of values. And what we would do is you would count how many of these values fall inside of these bins, which then leads us to the creation of a frequency table, something like this here, using the $1.50 example here, right? Using this $1.50 example, the one we have here, you would then create a frequency table with that information there. So you can take a look, just count how many fall within that. And so if you're 850, you go to this one, 849 would go to this one, and so forth with each of those lower and upper bound. You can see the frequencies, you can see the relative frequencies here. And then if you wanted percents, right, this one here, and put it in a different color, this would be 9.5% if you were going to put these into percent, right? Remember, multiply the decimal by 100 or move the decimal to, and this would be 28.6% and so forth. But you could go ahead and complete that relative frequency with the decimals there.